right, hey, good afternoon. Welcome back to the Collision Hub World's Fair. Our apologies for the delay there. We had some technical difficulties, but we got it squared away. It wasn't an electrical issue, I don't think.
No,
we're going to be talking about high voltage technology and EVs with our friend Scott Van Hooley from iCar this afternoon. So Scott, welcome to the World's Fair. Good to have you back.
Yeah, thanks for having me.
Awesome, awesome. So we have a lot to talk about today. Obviously, EVs and high voltage vehicles have become quite a topic in our industry. I can't go to a trade show or any industry event without some type of presentation or panel of experts talking about EV technology. But a lot of those presentations have been a little bit more on the diagnostic side of testing things, getting pretty in depth. I want to talk today a little bit more about the collision repair side of things when it comes to preparing my shop, moving the vehicle around. Where do I store the vehicle? Do I need a charging station? What's different on the vehicle structure? What has changed? So from a collision repair standpoint, what's different about these vehicles compared to a conventional internal combustion engine or other type of propulsion system? And there are a few differences for sure, but we're gonna get right into that. So, Scott, why don't you take us away and let's talk about when that pulls up in your shop for the first time.
Well, so that's probably one of the first things that is different, right? Is when a vehicle comes in on a flatbed, you can go in there, you can start tearing it apart, you can start the blueprinting process right away. There's no extra concerns really with that vehicle. With an EV, you have to be watching for things like the hot spots on the battery pack, which means different areas of the battery are heating up, or there might be a beginning of a thermal reaction. You have to watch for if there's any high voltage cables that are exposed or damaged, any of the components. A lot of these plug-ins for the high voltage charging cable are in fenders. They're in vulnerable areas that we have to be paying attention to. And if you have damage in any of those areas, you have to make sure that somebody that actually knows what they're doing is looking at it to make sure that vehicle's safe even after it's just coming off the tow truck.
Okay, so the first thing I need to do is, is that historically, the tow truck pulls up, drops the vehicle off, kind of on my merry way, but you're saying there's a few steps we need to do before that to protect ourselves and our technicians?
Yep, so you really have to just do a walk around that vehicle, understand what the state of that vehicle is, if there's any obvious damage that could be potentially hazardous, and you really need somebody that understands how EVs work and what those dangers are. So it might not be something that you're going to have the porter, come and help push into the shop without having somebody first go and look at it.
Sure. So yeah, that's aside from if you got some cut wires and stuff, that might be obvious. You might have some obvious battery damage, but there's probably some hidden stuff too that we need to be aware of that we may not be able to see as easily. Yeah.
So that's where these battery packs are extremely durable. They can take a pretty good beating and not have any problems. You could have some different oddball things where the customer ran something over and it punched a hole up through the bottom floor, and so some of the side structure wasn't there to take that impact, and you could have it where over time it starts to heat up because that battery has some damage, and once those cells started heating up, it can be that thermal event you don't want to have.
Okay. And we're talking more about thermal events in just a little bit, and hot spots, and then diagnosis, some of that. But before we get into the battery part of it, I want to talk a little bit about the structure of the vehicle, because we're seeing some changes in the vehicle structure. Now, you mentioned already the battery is extremely durable, very strong, but the vehicle manufacturers are also doing a lot of things with the vehicle structure around that battery. So historically, Collision Energy Management would absorb the frontal collision and then start transferring that around the passenger compartment. Now we've got an additional battery in there, so we're no longer protecting just the occupants, we're protecting the battery and thereby the occupants again. Yeah. But we've got now additional things and the vehicle structure has changed. So what we've got here is a couple of slides from Great Designs of Steel last year from Ford on the Mustang Mach-E electric vehicle. And this particular slide, they're talking about how they've added some additional energy transfer around that battery compartment. So whereas the past, where I could use the lower rails, the cowl, and a little bit of the floor even to help with some of that, now, as I want to get that around that battery compartment, we've got some additional bracing in there around that battery compartment. So again, is that what all we're looking to do here, is kind of beef up the area around the vehicle?
Yeah, I think that's one of the main concerns is, with a gasoline vehicle, that gas tank is kind of It's in the heart of the vehicle. It's protected by a lot of different things. Where these battery packs, especially on a full-on EV, it's the whole bottom of the car basically, or the SUV, whatever it is. And so you have that large surface area that really needs to be protected. And if it's a front-end collision or a rear-end collision, you have the rails just like for the passenger compartment that can do that and absorb that energy and transfer it around. But on those side hits, that battery pack a lot of times is right there behind those reinforcements. So they're really, really high MPA to really give that a lot of strength. And so, plus you have that lower center of gravity on the vehicle. And so I think the passenger compartment is probably even more protected because of it, but you're going to see additional reinforcements in places you haven't typically seen them before. So something that might look like it's a repairable one, all of a sudden these hidden reinforcements or underneath reinforcements could change how you approach that vehicle in a repair plan.
Sure. Now, this particular presentation is available online at the Great Designs of Steel Conference. I just posted it to the YouTube chat, so definitely check that out if you want to learn more about this vehicle. But a couple additional things about this particular vehicle. We don't have the slides to support, but what mentioned additional reinforcements behind the front wheels. There's an additional little plate that they've got on there, a bolt-on plate. Again, if there's any damage to that, probably going to be replacement only. It's a bolt-on plate. But they've also taken that rocker panel, ultra-high strength steel rocker panel reinforcement, and they've extended that to the front of the rocker panel area in hopes of, again, catching more of that collision energy management as it's gone around. So although we've been dealing with ultra-high strength steel rocker panels and not doing any type of straightening on them, now we've got more of a rocker panel in that area.
Well, and if you think back when they came up with a small overlap procedure or crash test, they started adding kind of those elephant trunks to the front that tied the upper rail to the lower rail and helped deflect the vehicle away from the damage. I think you're going to see some of that. That bracket you mentioned, I think, is going to have a part to play where instead of trying to absorb the energy, they're trying to get the vehicle to kind of ricochet off and divert it away from the damage. Yeah,
they're very big on that. And so the amount of design change that have taken place in the vehicle structure in the last 10 to 15 years has just been amazing. And we've been talking about it quite a bit this week. We talked with 3M yesterday about adhesive technology and structural adhesive versus panel bonding adhesive. We talked with Stellantis earlier about stacking and layering and how, again, that's built into the design of the vehicle, that collision energy management. And now we've got additional bracing, additional things that look like they're just, like, what is this part for? Well, it's most likely for collision energy management. They've got some additional bracing in the back of this vehicle. So again, I would definitely encourage you, if you have any interest in, like me, I get a kick out of these things at Great Designs of Steel every year with the vehicle technology. But yeah, check out that link, and there's a lot more in-depth information on the structure of it itself, and things that we're going to have to start thinking about and knowing that we're going to be replacing a lot more parts. Kink versus bend rule is probably out the window on a lot of this. If it's in an area where it's protecting that battery, if it's got damage on it, we're probably going to be in a replacement type situation.
Well, and even on a non-EV, just to touch on that structure a little bit more, a vehicle 20, 30 years ago that would be hit, and if it was a side hit, it would be a banana when it was done. You couldn't open the doors. Now that same vehicle, it comes in, it doesn't look like it was that hard of a hit, but that vehicle structure is so strong that it could take that energy, and it didn't look like much. So I think there's a big perception in the industry that's kind of been ongoing that, while it's not that bad of a damage on this vehicle, I should be able to repair it, but they don't realize the energy that went into that vehicle. And that's where you have to look at that structure a little bit differently, because it might transfer that energy, or it might just take that energy and not move at all because it's so strong.
Yeah.
And so it doesn't look bad, but it's been in a pretty major collision time at times.
Yeah, I think that's a great point. With the high strength steels, again, with the weld bonding and the adhesives and the crash toughened adhesives, I think there's a lot of questions yet about where is all that energy? Where did it go? Where did it dissipate to? Where does it absorb? Which, again, not to sound like a broken record, but we're going to. I mean, follow the OEM procedures when it comes to part replacement requirements, to part attachment requirements for it, because those continue to evolve. So, and again, it's not just the occupant, but that battery, and thereby, again, protecting the occupant.
And that customer interview is that much more important, because the vehicle may not have obvious signs of a severe collision, but if they can explain what happened, okay, I spun out and I went in the ditch, and now with an EV, we really got to look at that underside of the vehicle, because there's a puncture through that floor, it could have gotten to the battery pack.
Yeah, so again, we're going to be accessing those OEM procedures each and every time. If we can go back to the flatbed for just 1 second, one thing we failed to cover. So we've done our kind of initial inspection on it. We're going to get a little bit more in depth in what we're looking for. But once I get that off there, what about moving the vehicle around my shop? What about moving the vehicle around my parking lot? Do I need to have a paved parking lot? I mean, move these things around in and out every day. And we're talking about some of the fire hazards as well.
Yeah, with the paved parking lot, I think one, it's going to look nicer, but
sure.
Two, it does make it easier to move around, especially if you have to have jacks and dollies and things like that to move the vehicle around, because if it's something where it's an electric vehicle, it has regenerative braking, and so you're going to be charging capacitors, which we'll touch on a little bit later, and that's something you have to be aware of, is that even though you've de-energized the system, you could be introducing voltage into places that you don't want it.
Okay. All right, so let's get it off the flatbed and let's get it in the shop and start talking about what we need to do in the shop. Now, this looks like something out of like the Corvette Museum or something when I go there and they got it all roped off. What do we got going on here?
So basically, most of the OEMs, they recommend 16 feet all the way around the vehicle, front, back, and side. And that's just to kind of give the technician on it working on the vehicle, give them enough space to keep people that shouldn't be by that vehicle away from the vehicle.
Such as people that aren't trained on how to work around high voltage batteries.
Yes, especially people that aren't trained around it. There was a case a few weeks back where a high voltage technician in Germany had the battery pack opened. He tripped and fell onto the battery pack and died. So he was actually trained, freak accident. He fell where he shouldn't be, and because of that, he lost his life.
That's unfortunate.
Yeah, and that's the biggest thing that you got to take away is the vehicles are safe to work on if you know what you're doing, but you don't get a second chance.
You don't get a second chance.
We talk about the 12-volt battery. You drop a wrench on it, it flies, you get some sparks. You have a ring on while you're working on something, and you contact something, you burn your finger. EV, you don't come back from that.
You don't get another chance to do it.
That's the one part that, as long as you are aware of it and can appreciate what that vehicle has in it, you can work safely around it, but you have to always be vigilant on what you're doing.
And this is probably something I want to make sure that I've also conveyed to, if I've got people that I'm dealing with that are coming into my shop, whether it's a job or whether it's someone from an insurance organization, coming into my facility. Again, I don't want them anywhere near that vehicle either, right? I only want to train people near it. I want to make them aware that we've got these vehicles in there. If I'm even let them into the shop at all, right?
Right.
So again, signage. Looks like we got some signage on there as well.
Yep, we got the signage on there. We rope off the area to keep people out so they don't wander in and, hey, that's an interesting looking car, and they go walking into that area. But there's also some signage that we have to signify to the trained people in the building what state that vehicle is in, if it's safe to approach it. So like a green tag would be indicating that it's safe to work on. Yellow, they're doing testing, and red is stay away.
Okay.
And the reason that they give that 16 feet also, so that's inside and outside. So if you have a vehicle stall, they want that gap inside the building and also outside, because once the battery pack does have a thermal event, and that happens, it's kind of it's not a...
That's like a fire for us laymen, right?
Yes, okay. But it's a very different fire, because you can put all kinds of water on it and you can take away the heat from that battery pack, but once it starts on fire, you can't put it out. It'd be the same thing as mixing body filler with a hardener. Once you mix it, you can't unmix it. Okay. It's going to cure, it's going to go and run through its cycle, and there's not a lot you can do about it. And so a big part of this is a normal fire. I read some stuff on the fire protection website that normal fire is like 1,500 degrees, somewhere around there. But some of these materials inside these battery packs burn at 2,000 or 3,000 degrees. Okay. Magnesium is one we know all too well, that once that starts on fire, you just kind of got to let it run its course. And so that's why they want that extra room around the vehicle to make sure that if it does start on fire, it's not going to catch anything else on fire.
Sure. Now, to help with these thermal events as well, we've been talking about taking vehicles from the shop that we're working on their day and bringing them outside at night. Any thoughts around? I mean, do I need to have now a separate area for those vehicles potentially so that they're not near other customer cars? And what if I've got 2 or 3 EVs that I'm working on? What are some of the logistical challenges around that?
So I think that depends on, there's a lot of unknowns because a minor damage vehicle that you've done some of the testing on and things like that, there's a lot less potential. So it's kind of situational based.
Okay.
If it's something that's a really hard hit and you're not sure about that state, and maybe it's something that it actually has to go over to dealership for them to take a deeper dive, that might be one that until you get that high voltage expert to take a look at it, it stays outside, just in case there is a problem. But the next step here, our pre and post scan, the pre-scan in this case is more important than ever on an EV because we're not just pulling DTCs, we're actually looking for the live data.
Okay.
And so on the live data, so when we talk about a thermal event, it starts with some of the cells start heating up. And as they start to heat up, that heat just keeps building and building and building. And so when you're going into this live data, it'll show you that, hey, this battery pack is starting to have a hot spot. There's some of these cells are starting to heat up. You're going to want to get that vehicle outside because that's a sign that it could potentially have that thermal event.
So are we looking at any hot spots here? What are we looking at here?
So on this particular scan, this battery is in a good state right now.
Okay.
You can see all the different packs are the same temperature.
Okay.
And so that's what you're looking for. If you start to see variations in that, that's when you're going to really want to monitor it closely. And that might be where you contact the dealer and try to get a high voltage expert either to come look at it or get it over there for them to look at it, because I don't think anybody in the collision industry should be ever taking these battery packs apart.
Sure.
Because that's now you're working under live conditions. So we want to get that battery pack to a state where we can safely work on the vehicle, but we're not going inside that battery pack because that's a whole nother level of training. And really, you have to be a true expert before you can get to that level.
Okay. Now I see we've got some, we're looking at what, 18C here, 18 degrees C. Are there parameters that the OEM is going to have for us? Are they going to give us a range? Or am I just looking for if I got 18, 18, and 36?
Yeah, if you see something like that, that's your first red flag. You're going to have to go through the OEM information to find what their expected range is.
Okay.
If it's a really, hot day in Arizona, and as a black car, you may start to see some of that, be a little bit higher. But if there's a big variation, that's a big red flag that you got to watch out for.
Okay.
So then we also will look at the state of that battery, and it'll tell you how many volts it's set at, and just kind of what the health of that battery is. So, the pre and post scan that everyone talks about, so many people still to this day think it's clearing codes. It's really not. It's documenting it, and when you bring this vehicle in, you're making sure that everything is the way it should be, it's even, and there's no problems. And this is kind of the snapshot in time, because we're even starting to see it where even after the vehicle's been repaired and delivered back to the customer, you might want to have them come back a week after or 2 weeks after to check this as well, because some of the places where EVs are more prevalent, like in Europe, they're finding that some of these vehicles get delivered back to the customer and then they have the thermal event in their garage at their home. And so, but by checking it that week or 2 weeks, usually it'll start to show signs of problems in that window from when it was repaired to delivered to the customer. But as a safety check, it might not be a bad idea to have them bring it in.
Schedule a follow-up appointment with them, have them come in, take a look at it.
Yep.
And we got live data, you say here, so we've got a scan tool hooked up there, and so again, if I'm having that conversation again about what scan tool to buy, if I'm going to be working on some of these EV vehicles, I'm going to want to make sure that I've got a scan tool that's capable of getting me the information that I need.
Yes, and that's the biggest thing, is it has to be capable to get in there and look at some of this stuff, because it can tell you a lot of really valuable information, not only for the safety of the vehicle, the customer, but just in diagnosing what's actually going on. If you have that live data, it can tell you a lot.
Yeah. Okay.
And that's not just for EVs. That's a lot of these systems now. It can actually give you a lot of information that you can use.
Okay.
So we touched on this a little bit. So basically, this is a really neat little chart because we talk about airbags deploying in milliseconds, and in the amount of time that you would grab onto something that's high voltage,
Yep.
we're talking milliseconds here, and you're done. You're not going to be able to let go. So that's that let go threshold.
Okay.
It's not many amps. When you're dealing with this kind of voltage, it doesn't take a lot. It's very quick. And they talk about the safety hooks that they always have. The OEMs always have a safety hook to pull somebody off an EV. It's not to save their life. It's to prevent somebody else from touching them and being killed.
Okay.
So it's more of recovery than it is for saving someone.
Okay.
So that's something that, you have to, again, be aware of.
Pretty short amount of time and pretty small amperage can do a lot of damage.
Yep. So it doesn't take much. And, you start getting into the direct current high voltage. I believe it's 60 volts is when it starts to enter that high voltage range. And a lot of these ones are running at 400 volts.
Okay.
So there's no forgiveness at all. So charging stations.
Yeah, charging stations. So that's a big one, right? So I'm starting to see some more EVs in my market. Maybe I've had one come in, or maybe I haven't yet, but I know that one will come pretty soon. And from a customer service standpoint, from making sure I can get the vehicle back to the customer with a full battery charge, what do I need to equip my shop with in order to be able to handle the EV emergence?
So there's a few different options. You see we have the level 1, 2, and 3, and it's basically a 110 volt, 240 volt, and then up to the 3-phase, which is a direct DC direct current that basically takes the voltage off the line, changes it to DC, and puts it directly into the battery. So that's going to be super fast charge, dump a lot of power into it. With both the level 2 and 3 chargers, you really got to watch out for maybe some of the knockoff ones. If it's from a website that is maybe a little bit shady, but it's really cheap, it may not have a lot of the cooling capabilities or monitoring of that voltage going through it, because as that, especially on the DC fast charger, the level 3, there's a lot of heat produced when you're having that much energy go through that cable, and if it's not being monitored and not being cooled, you could actually have problems with that as well. And the level 3 chargers are pretty expensive.
Okay.
And you may not even have enough power coming into your shop.
Okay.
So if you have problems with spot welders not having enough power in your shop.
I think we have a few shops that have problems with spot welders.
The level 3 probably isn't going to work for
Okay.
you. You won't be able to get enough power to actually get the full value of it. The 240 volt, that's probably going to be the workhorse. They're not overly expensive. You do have to look at the infrastructure again to make sure you have enough power coming in for it. And one thing to think about too, within a few hours on a normal battery, that level 2 charger can fully charge it up. Where the level 1 charger, if it's really low, it might take 3 days to charge that vehicle up. It's basically like a trickle charger compared to the normal setting on a battery charger.
Okay, so level 1 is probably not going to be in my shop?
Probably not. It just doesn't have enough capacity to charge it like we need to.
Okay.
When you start looking at level 2 and level 3, so you can kind of think of it from inside the building and outside the building.
Okay.
So if you might have a cheaper cable system that has a monitoring for a level 2 inside the shop because you're not charging necessarily the customer. And then out in your parking lot, you could have ones that actually, you could become an EV charging station for EVs in the area. They can come at night, put in their credit card and pay. So there's a lot of different options that you have to look at for that. Again, how much that electrical hooks up, and if you're going underground with it and things like that, those are all costs you have to look at. But so a lot of times that level 2 is probably going to be all you need, unless you want to have some of that on the outside of the building as well for customers coming in.
And how do I evaluate if let's say I'm going to get a level 2 solution? I think is going to be the best for me. How do I know how many stations I should have? What type of information is out there for me to research to help build my EV infrastructure?
There's not a lot. I think you really have to take a look at your business, how many EVs you have in your shop at any one time. If you're you have a dozen EVs in there every day, okay, then you're probably going to need a dozen chargers at each stall. If you're seeing one here, one there, you know, they run conduit from the panel to wherever you need it to go, so they can set them up relatively easy. It's just the extra costs and things like that, so you can start with a couple and then build it out as you need.
Okay. Yeah, I really like the idea, for me personally, if it was my shop, if I'm working on EV vehicles, I like to have that something accessible to my community that, you know, maybe if I'm in a downtown location, if someone just wants to have lunch, they can park their car at my facility for a little bit, you know. I think there's a lot of marketing benefits, soft marketing benefits for us as a collision repair facility as well, to get in there and let, hey, we've got an EV charging station, or we're equipped for repairing your EV vehicles. And I think that, you know, right now is the time to kind of get ahead of that a little bit. I'll be catching up to you pretty soon, I think, but there's probably still a little bit of a window for me to kind of be that, hey, I'm the EV shop in town.
Yeah, and the other thing for the shop to keep in mind, even when you have these chargers, if you're working on the high voltage system or any components of it, make sure it's unplugged while you're doing that, because when you plug in the charger, the contactors are closed and power is going into that battery. So now that high voltage system is energized, and if you're taking something apart, you could have full battery voltage at that connector that you're pulling off, even though you had it had somebody go through and make sure it was all dead, and all of a sudden you plug it in because, oh, we want that battery charged. Now everything's live again.
Now, if I'm going to make this investment, and I'm thinking about where should I start my research to find out, you know, who should I buy from? Where should I be, you know, looking from? And do I buy this? Do I lease it? What are there other options out there for me?
There are a lot of different options. Some states actually have different programs to set up an EV charger, especially on the outside of the building. So check with your local municipality, the state. There might even be some federal ones out there yet. But so you can start doing that. You know, a lot of these companies, they'll walk you through and they'll work with you on, okay, what are you looking to do?
Yeah.
And they will give you some different options and shop around. There's a lot of these that are, there's companies that are making these and then they're rebranded for other companies. And so you kind of do your research on that and see which one works best for you. Look at, you know, how much the charging rate is, because if the kilowatt hours on one is really low and the other one's a little bit higher and about the same price, well, that one has more capacity to charge faster than the lower kilowatt hours. So there's a lot of different nuances you got to pay attention to, but just do your research.
So like anything else, right? If I'm buying a new spot weld or any other equipment, I want to make sure I'm doing that. So do your due diligence, and you know, and pick the best solution for you, but give you that option to expand in the future, I think, as well.
Yeah.
Okay.
So we touched on this a little bit. This was something we developed to really address EVs in a collision repair facility. So we brought all the industry experts together, from insurers, OEMs, collision repair shops, tool and equipment makers, our own EV experts.
Yeah.
That
you've got a couple of them, don't
yeah,
you?
that thankfully we have, because they were instrumental in developing a lot of this. But it really, when you look at the service information, it's set up for a service technician.
Yeah.
They have a single fault, and we're kind of a broken record on this too, where it's set up for those simple situations where we have a vehicle that all these safety systems may be compromised. We don't know the state of it. We don't know what happened to this vehicle. And so we have to approach all these vehicles in a very precise way and the same way each time, because then it eliminates errors. A lot of the steps that are a part of this procedure, all the OEMs have them as part of their procedures, but they might be in one section and then another section, and it's all over the place, where this best practice lays it out in a single document and walks you through step by step. You still need the OEM information to reference,
Right.
But at least we have a consistent way, no matter what the vehicle is.
Kind of a standard operating procedure around
Yep.
the best practice. And just for what it's worth, I always think it's important to mention this. When it comes to ICAR published best practices, it's not Scott and Dirk sitting in a room coming up with these best practices. these are inter-industry developed and vetted best practices that ICAR publishes.
Yep.
So they're facilitating the conversations, but ultimately it's the inter-industry's input into what goes into these best practices, whether it's EV, whether it's the rolled hem flange quarter panel, sectioning of the same location twice again. So it's really getting the industry's involvement for these best practices. And again, they complement the OEM procedures. They never will supersede the OEM procedures. This is designed to complement you and kind of give you a step-by-step process that again has been developed and vetted by industry subject matter experts from OEMs, insurers, and collision repair facilities.
Yeah, because even the insurance adjuster coming into the shop, they need a level of training and understanding to know what they're looking at. And that's one of the things that is a little bit of a curveball with EVs is everyone has to educate themselves, and there's, quite frankly, a lot of people that have not done that work yet.
That's for sure.
So special testing tools. So this is where Dirk really...
Milliohms, I'm
Yeah.
sorry, I'm
Yeah,
smirking here.
The milliohm meters, and we got an equation later we'll go over. But this is where, these are tools that are unique to high voltage. So you can have a technician that is an ace electrical technician. He's your mechanic, he's your electrical guy, but he doesn't have the installation tester, which looks a lot like a multimeter, but it's very different than that. You might need a high voltage digital volt ohm meter, and the milliohm meter, we're used to measuring ohms.
Mm-hmm.
This is a milliohm, so 0.0001.
0.01, yeah.
I got to count my zeros. And so it is next to nothing in comparison to an ohm. So when we're ohming out a wire to see, if it's pinched or broken, this is measuring to a degree that we can't even fathom.
Okay.
So it's very, very sensitive. It's, it's a 4-wire, and Dirk goes into quite a bit of detail on that. But it basically, it's testing that system. It's sending out a certain amount of amperage and voltage to do the testing, and so it's a very specialized tool. They're not overly expensive. There's quite a few different brands out there, but you have to make sure that, I believe it's Cat 3 for a lot of these, where that's allows you to test at the high enough voltage.
Okay.
So there's different voltage ratings, and we have some articles and stuff we'll touch on in a little bit that cover some of that as well.
And if you want to go back and look at, was it last spring's presentation from you and Dirk? We had Dirk and Scott here last year talking about EV vehicles as well, and you can get the Dirk explanation, the entertaining Dirk explanation if you're so inclined to do that. So go to our the YouTube page and look at our last year's World's Fair for the ICAR EV special and get brushed up on your German.
Yeah, we have fun with Dirk, the Dirklish.
Turkish, yes. I forget what the one word he was trying to spit out last year that wouldn't come out.
I don't remember either, but so the battery disconnects. This is something that we've been dealing with hybrid vehicles for a long time. I don't know that everyone is fully up to speed on it. I've heard stories of guys picking up the battery pack and hauling it around with no gloves on out of the vehicle, and they said, well, you just got to keep your hands out of the connectors, and it's
true, I guess, right?
Yeah, but again, that potential for a really bad day.
Why risk it?
Yeah, it's just not worth it. So, and each one of these vehicles, they seem to have it in a slightly different spot. There might be a different way to disconnect that actual disconnect.
Yep.
There's a lot of times there's 2 or 3 steps to it. So you have to be aware you don't want to break some of these disconnects or connectors because sometimes they're not serviced.
And so you mentioned there might be 2 or 3. There's also multiple ways sometimes to disable the battery, right? Use a scan tool or a manual operation.
Yeah, a lot of times you're going to do 2 different disconnects on it to totally disable the system. A lot of them have the actual battery disconnect.
Yep.
But then a lot of them will have the service disconnects, and some will be a scan tool disconnect. But usually, you're going to be doing kind of a combination of them.
Yeah, and I forget which vehicle it was now. I wasn't prepared to have that conversation, but I remember one of them, I think, has got you can either hook the scan tool up and you push a couple buttons and it disables it, or there's a lengthy process and then you got to go back and test it with the scan tool afterwards or something.
Yeah.
But so again, read the OEM information, follow the procedures, and then disable according to what you have at your disposal.
Yeah, so you'll have kind of one of the three where it's like a 12-volt battery disconnect or actual service disconnect, or the green one there, the little interrupt one, so that service information will tell you what you need to do it.
And are there any tools on the RTS website about disabling hybrid and EV batteries? There are.
Yes. There's the hybrid disable search, hybrid and electric vehicle disable search. And that we give you step-by-step instructions on where to find the disconnect procedure, so you are always getting the most up-to-date procedure you can from the OEM. We did that because we want to make sure there's a lot of nuances and different things that can change that you need to be aware of. So go to that service information and get that, because then you know you have all the pieces you need.
And those are oftentimes going to differ than the emergency rescue personnel disable procedures.
Yes.
So be aware of that as well, because there's a wealth of information on emergency vehicle or emergency personnel, how for them to disable high voltage batteries. Probably not the practices we want to be using, but be aware that again that vehicle coming in may have had some of those performed. So again, knowing what those disable procedures are helps you inspect to determine whether or not the rescue personnel disabled and cut some wires or did or whatever they did.
Yeah, because they all of a sudden they cut out a chunk of wire that big and it's a loop. You're not gonna fix that. You got to know that that's what happened.
So just from an awareness standpoint, to know what the EMTs, the rescue personnel might have done to the vehicle already, I think it's another good kind of not a best practice because it hasn't been vetted, but another step in the process to determine kind of what you're dealing with, so that before it comes off the flatbed conversation.
Yeah. So capacitors and wait time.
Okay.
When I say capacitors, what do you think of?
Flux capacitor.
Yes. So I have a feeling most of the collision guys will probably answer the same thing.
That's all you need.
But so basically, these high voltage systems, they have capacitors to store that energy temporarily, and even after you disconnect it, it's kind of like the airbags, where you disconnect the battery and you have to wait a certain amount of time, because there's a backup battery in case there's an additional rollover or anything like that happening after the collision, and so you got to basically allow that to discharge.
Okay.
Typically it's around 5 minutes. Sometimes it's longer. Again, the service information, but these are one of the things you have to watch out for if you're pushing the vehicle on the wheels. You could be charging it. You could be having those things happen. So when you can avoid it.
So we're still not pushing vehicles around on wheels? Want them rolling?
Not the best idea to do it.
So again, back to our conversation about having that paved parking lot versus a gravel parking lot potentially. Want to put out and back. Might make life a little bit easier to move them around a little bit.
Yeah.
Okay. Now, what about the battery? One thing we didn't touch on, is the battery itself. If I take the battery, should I be looking at, am I be taking batteries out? Am I be storing them? Do I need a lift? I know there's nice scissor lifts that are out there. Do I need one of those?
If you're going to be doing, so a lot of the hybrid batteries, they were fairly small by comparison. If you're going to take down the skateboard kind of one, you're going to need a lift that can hold that battery because it's heavy. And you need one that can adjust and get it leveled out, because again, you're over a large area, you're holding this battery. The other thing that people don't talk about, I know Mark Allen from Audi always makes sure that we talk about this part, is you have to also have enough buckets or something to catch the coolant out of these batteries, because there's a huge amount of coolant in that battery pack that when you're taking it down and you're going to drain that coolant out, I believe it's 5.5 gallons. Okay. So you got a 5-gallon bucket, it's not enough.
It's not enough.
You're going to be a little bit over capacity there. So there's some things there that you have to pay attention to. So the battery lift is probably one that you're really going to look at. What vehicles are you working on? Okay. Because if you're working on the new Audi, they have a very specific lift for that large battery on there. Tesla, I think, has some of their own lifts. And just kind of look at the vehicles and look at the repair information and what they have for capacities, and judge what you need for your shop.
Okay. And if I do have a battery out, I'm storing it, are there storage concerns? Again, do I need that 16 feet still? Am I looking at something different?
Yeah, I think, if you know the state of that battery, but once the battery pack is out, Now it's a little harder to monitor it. You might actually need to take, I know there's some adapters for smartphones where it can actually become an infrared camera.
Okay.
So you could monitor the battery that way, but you lose a lot of the abilities of the scan tool to plug in, and you don't have that live data. So yeah, so there might be some, if you're taking that battery out, you might want to have that away from everything else so that if there is a problem, it doesn't burn down your whole shop.
Okay. But if I've checked my live data and I've got pretty good numbers and I feel pretty comfortable with the battery intake, hasn't been compromised. Those are, again, all kind of indicators that, I don't want to say fail for sure, but they're kind of indicators that it may have a pretty sound battery and maybe a little bit less of a thermal event hazard.
Yes. So now kind of one of the next steps, and I love this slide that Dirk put together because we got this nice formula up there that means a whole lot of nothing to most people. But it really starts breaking it down. So basically, we were talking about like the milliohms and measuring that. So when you have those connectors, if it's functioning like it should be, at the first one there, you got enough heat for a light bulb, a 90-watt light bulb. But then if you get a little bit of overspray on there and you go to 1/10 of an ohm, or no, 1/100th of an ohm.
100th of an ohm, yep.
Now you're at 900 watts, which is now a toaster. So now you're getting a lot more heat in that battery or a lot more heat in that connector.
Got more resistance in there.
Yeah, it's building up very quickly. And then when you're at 1/10 of an ohm, now you're at 9,000 watts, which is basically enough to power your entire house.
Okay.
So now you have all that heat in one connector, and that's where you could start a fire from that. And you could do it from the overspray, just dirt and grime getting in there. You may not even be able to see the overspray on that connector, but just that fine mist that we sometimes get can cause some of those resistance to go up quite substantially.
So if I've got these connectors disconnected, I need to be protecting those?
Absolutely. So just like we do with the AC system, we're always capping that off. It's open any amount of time to help keep moisture out. This, you're trying to keep all the contaminants out because even these connectors actually have a life cycle on them where after they've been cycled so many times, they're supposed to be replaced.
Okay.
So, that every time you're taking that on and off, that's a life cycle for that. So you have to be aware of that. And then if you're getting dirt or grime or body shop dust in those connectors, you're just asking for a fire.
At one point, we used to always talk about how a bad paint job never killed anybody, right? Nobody ever got injured because of a bad paint job. Well, between this and ADAS systems and painting over bumper covers, putting too much film thickness on there, I don't think we can no longer say that a bad paint job doesn't have the potential to hurt somebody.
Yeah, and I know I've seen it.
It hurts your eyes.
Yeah, it hurts your eyes, yeah.
But now you can...
Well, it comes in and there's overspray on the windshield and there's overspray on the door jambs, and it gets into places you wouldn't expect, but if you have that connector for the main battery harness and it's hanging down underneath the vehicle, we all have downdraft booths, and all that is now that dust is going in there and you may not be able to see it.
Okay, so I need a cleaner spray booth than I used to for my refinish jobs. You need to be covering up all these connectors.
Yep, seal them up really well right away so that they're, after you've got all your testing done, get them protected, get them under cover so that you don't have any of these issues with them heating up, because we don't want to turn your electric vehicle into a toaster.
And we've got some thermal event pictures, don't we, from some connectors here?
I believe so, right
that.
there. So when they start heating up, these connectors are built to really try to keep your hands out of there.
Okay.
So you'd have to really do something bad to get your hands in there.
Got it.
But dust doesn't mind. It goes right in there very easily. And so, if you're disconnecting things under full power, you can really do some damage. That's why they have for the safety, the PPE, they have a lot of the arc flash shields and things like that, because if you screw up and you disconnect something that has full power on it, it's not a good thing either.
So you mentioned PPE.
Yeah.
I know we haven't touched on PPE a whole lot, but Class 0 linesman's gloves, need those. You mentioned other safety equipment. Do I need to have that in my shop?
If you're going to be into certain situations where you're actually disconnecting some of these high voltage systems, it's not going to be a bad idea to have the guys wearing it. If you're unsure of the vehicle especially, you could potentially, even though the vehicle may appear to be disabled, you could have a situation where something has live voltage and you have to be aware of it. So the PPE, until you know that vehicle is safe, that's when it's the most important to have on.
Okay, safety is no accident.
Yes.
All right.
So when you see this slide, what does it tell you?
Well, looks like he's being used as a bit of a conductor there between module 1 and 2. That's an electric current going through him potentially.
Yep. So, you look at the electrical diagrams, and if you're not in electrical work a lot, it doesn't make a whole lot of sense.
Mm-hmm.
But basically, they have this system set up where if you touch one component that's high voltage, you're okay.
Okay.
If you touch two that aren't bonded, you're not okay.
Okay.
So because all of a sudden you're connecting it, because it's isolated from the actual vehicle. Because 12-volt system, all your grounds go right to the chassis, right? And we paint over them, we forget to hook them up, we got a few weird electrical gremlins in there.
And we take it off and scratch it off and we're good to go.
We're good to go.
Yeah.
Where this, it's a dedicated kind of bonding that they do to make sure that that current can't go into the chassis, into the vehicle, because it would go to the customers and things like that. So
Okay.
here, if we're not hooking up, these bonding cables, you could potentially really create a very bad situation for somebody where they have that day they don't get to go home ever again.
Okay.
And so that's where, when you're taking things on and off, that's part of that protocol or the best practice that we put together, is you're checking all those things to make sure that, and understanding what the reading will be if it's not hooked up correctly. So that's probably the biggest, one of the biggest things is, as we're reassembling these vehicles, you can't miss these bonding cables, because
Okay.
that's what's keeping you safe.
All right.
So, and that's one of the things the OEMs built into the vehicle to make sure that they're safe. And now, after a collision, how many of them have been disabled and damaged? And that's why we have to approach it a little bit differently.
Okay.
So, another little eye test for you.
Holy cow. Looks like I need to understand wiring diagrams a little bit better than I do.
Yes, just a little bit. So, the isolation testing, basically, you have to go through the system both ways, because some of these components only allow electricity to go one direction.
Okay.
So if you have a problem on one side of the circuit and you only test it from the other way, it will never get there because it doesn't let it through. So you have to test it. You have to test it both ways. So the high voltage to ground and ground to high voltage,
Okay.
and it'll go through the circuits and check everything. But looking at this picture, without that education, you're not going to understand what this is even asking you to do.
And I think that would be a lot of our technicians in a lot of cases.
Yes. So if you have a mechanical technician, he's your electrical guy, he probably could look at this chart and understand it pretty well, but he may not be as well versed on high voltage.
Yep.
Just because you know basic electrical doesn't mean you understand everything you need to know for high voltage.
Yeah.
So it's kind of a different animal.
It is, Scott, and here's where I'm going to get on my soapbox a little bit when it comes to, we talk about these technician shortage, we talk about, some of the challenges in the issue, or the challenges in our industry. We talk about, technicians that have been in the industry aren't familiar with this stuff, certainly in a lot of cases. A lot of technicians aren't comfortable working around the ADAS systems and advanced driver assistance. It's just a foreign world to them. Mm-hmm. We're structural technicians, and I've been welding, and I can do panel replacement, I understand three-dimensional measuring, I can do all those things really good, but this is an area that, as a collision repair technician, I'm not historically comfortable in. And I think whether it's EV, ADAS, or the combination of the two of them, I think that this is a huge opportunity for the industry to start looking at that next generation of technicians that grew up with, the digital natives that grew up with a tablet in their hand and a smartphone in the other hand, play video games all day, but they also kind of like cars. Mm-hmm. I think that this technology is a great way to introduce, the next generation of technicians potentially to our industry. It's different kind of work. It's work that our traditional collision repair technicians, I would argue, probably don't want to do in a lot of cases. But if I'm reaching out to a recent graduate of maybe an automotive service program, or maybe a collision repair program that's incorporated a lot more of this into their curriculum, although I don't think there's a lot of schools that are at this point yet, but I'm sure there are several that are certainly into it at some level. Or maybe if I look at a student that graduated with electronics degree potentially, or other backgrounds, I just think that this particular topic, EVs, ADAS, just collision repair diagnostics in general, provides us with a great opportunity to attract some future technicians into good paying jobs and steady work in the future, especially as we're going to be cutting off more parts than we have in the past. We're not going to be doing as much straightening. I just think there's a lot of opportunity in this area, to bring in some fresh talent, some young talent. You got any thoughts on that?
So I think one thing that to add to that, you also can't assume that the mechanical shop that you sublet to, that their technicians understand this technology
I
either.
think that's a great point.
And so I think even on the mechanical side, they're struggling with the same thing. It's a new technology. There's not a lot of experience with it, and they're starving for that knowledge and that training, because the high voltage is different. So I think how you interact with even the service department at the local dealer or independent shop that you sublet with, you're going to have to really make sure that they understand what's going on and understand how to communicate what happened to that vehicle, because it's no different than with the ADAS when they send it over and say, yeah, calibrate it, if they don't know what you really mean.
Right. Why?
Right.
Why am I doing this?
We don't have to do that ever.
So what do you put a windshield in? A big deal.
Yeah. Where we're kind of on the bleeding edge of it with collision, and so you have to make sure that you're communicating with your staff and any of your sublet vendors as well, because you can't assume that they know what they're doing or what's going on.
Yeah, I think it's, aside from the relatively small number of independents and dealership technicians that have gone to an EV specific OEM program, there's not a lot of them, not a lot of other expertise out there.
Yeah.
So it's going to have to get ramped up for that. So, what's ICAR doing to help some of those situations?
So, one of the first things on the RTS website, we have quite a few articles on it for understanding some of the different basics of high voltage vehicles, safety information, and it's actually on that hybrid and electric vehicle disabled search. Yeah. Rolls off the tongue every time. There's a button on that page when you go to do the search, and it's called what we call a hotspot. And so it's got a series of articles that all have to do with high voltage vehicles. And take your time, and just if you want to start understanding some of this, start there, because that'll actually prep you for the actual training that your guys are going to need, or you yourself are going to need. It's really there to bring awareness. People want a checklist of tools. We have an article that we kind of go over some of those vehicle special tools and equipment that you're going to need, and call that out, because with ADAS there's a lot of targets and different things that you need to do, and the space requirements, where EV is a little bit more streamlined. High voltage is high voltage, and maybe how the OEM handles it is going to vary a little bit, but you can't change physics.
Ohm's law hasn't changed, you're saying?
No, Ohm's law hasn't changed. I think I finally understand Ohm's law.
That hasn't been canceled yet.
Yeah.
For the time.
Yeah. But yeah, so those articles are kind of that first step to kind of go on that journey a little bit, watching videos like this, really just start to kind of wrap your head around it.
Okay.
And then from there, we do have quite a few training courses on that. We have some that are specific just for damage analysis, inspecting and handling, so kind of that real basic entry level information, how to approach that vehicle that's just towed into your shop. Okay. We go through that in the training. So they kind of broke it down this way a little bit, where it's really that staff safety. So everybody in the shop can go to the training, it's online, and you understand okay, I can't go near that vehicle because it's got a red tag on it or a yellow tag, or whatever our SOP says, I can't go anywhere near that vehicle. That's kind of step one. And then you get a little bit more in depth where maybe they can work on the vehicle after it's safely been disabled. But then the kind of the end of that program, we have a 5-day hands-on EV course that will be coming out this summer.
Oh, 5-day hands-on EV course.
It is intense. We actually did the class at WorldPack where we had mechanical technicians that they attended the class and they were coming in early and they were staying late because there's a simulator cart, so they have a written test, and then there's a simulator cart that we put bugs into that you actually have to diagnose what's wrong with it to pass the class.
Okay.
And now these are people that are very well versed in
Sure.
electrical diagnostics. They understand voltage drop and all those kinds of things. And that class can take somebody from, with the prerequisites that we have, so you have to take some online classes
Okay.
before it, and then do that 5-day EV training, but that'll get you that baseline
Okay.
to work around these EV vehicles safely and actually know what you're doing on them. And then there'll be additional training that you'd have to go through for the OEMs
Sure.
on their specific, sauce for that battery.
Okay.
But that 5-day hands-on EV course, you can come out of there and the technicians, if they pass, are going to be pretty confident working on those vehicles. But the whole point of that training, it gets you to a point where you look at that vehicle, and if you find an anomaly that shouldn't be there, and there's high voltage where there shouldn't be, you're now stepping back,
Okay.
and now it's going over to a high voltage
No
expert
win
at a
to say
dealer.
win, eh?
Yep.
Okay.
You're not cracking the battery open or any
Yep.
of that. It's very regimented for a reason, and that's all kind of following the European model from Germany, where they have very strict rules on who can even look at the vehicle,
Yeah.
let alone touch it.
Okay.
So, but kind of using that as a template, that 5-day hands-on EV course, I've been through it. I'm your average collision tech. I didn't understand a lot of electrical. The exercises we have in that class, I learned more in electrical in those 5 days than I did my entire life before that.
Will that be available at the Chicago Tech Center? Is that where it's going to be?
That's going to be out of the Chicago
There
Tech
only?
Center.
Okay.
Yep. And you should see that sometime later this summer.
Okay. Awesome. Cool. Anything else, Dad?
I think we talked about a few
It's
things.
a lot. We got anything coming in, Jordy? We good over there? No questions? All right, cool. Well, it's always a pleasure.
Yeah.
And some good content, good information. And again, I think something that we had kind of been lacking, talking about the collision repair part of it. And again, I think we've been milliomed and DVOM to death. I think it's good to have a good practical collision repair conversation about, again, when that vehicle shows up, all the way through that repair process and protecting ourselves, protecting our employees, and certainly protecting our vehicle occupants so we give them their vehicles back a complete, safe, quality repair.
Yeah, and that's the whole basis of the training is making sure that everybody knows what they can do, what they can't do, and when they should do it.
Awesome. Well, thanks for your time, Scott. Really appreciate you making the trip down here. We will be back at 4:30 this afternoon with 3M, and then 6:30 this evening with Celette. We're talking about some pulling strategies on late model vehicles, so that one should be pretty entertaining, I think, and very informative. We've got the Celette guys here, and Larry's going to come out. We're going to have some debates about what we would do to pull our Sentra here, so that should be definitely entertaining. So again, 4:30 for 3M and 6:30 tonight for Celette. We look forward to seeing you then.